Well, welcome to today's episode, everybody. We've got a really exciting guest, Axel Kloth. And Axel is a physicist and computer scientist by training. He's the founder and president and CEO of Abacus Semiconductor Corporation. And he was also the founder and CTO of Axioto, an AI-enhanced security processor company. For those of you just joining the podcast, we at Strativa AI help businesses scale their revenue over 12 months using AI. So if you want to learn how to take your business to the next level, be sure to stick around for future episodes. And as well, if you're interested in receiving a free growth analysis for your business, please drop the word DM into the comments. Axel, welcome. Thank you so much for taking the time here today. And thanks again. Appreciate it.
Thanks, Mark, for having me.
How's it going?
Thanks for having me.
Indeed. Yeah. So, Axel, could you tell us a bit about your background and what your role is at your current company, kind of your background about what got you started in the whole field?
Sure. My background as a physicist and computer scientist is exactly what it says. I studied physics because I always like to take things apart. And, sometimes you put them back together and they work, and sometimes they don't. And sometimes they work actually better than they worked before. And I've applied the same to computer science because ultimately I believe that computer science and everything we have built around IT is an enabling technology. And that has become even more enabling for everybody with the advent of artificial intelligence, particularly the generative part of artificial intelligence.
Very good. And so at Abacus, what is it exactly that your company does?
We're developing processors and accelerators and smart multi-home memories for AI because ultimately today what we are seeing is that there is a solution out there that works well. It's just not necessarily financially always feasible to use those solutions in data centers that have been rehomed because very simply the power consumption is incredibly high and not everybody can afford to build a nuclear power plant right next to their data center, right? In fact, most data centers that have been rehomed, they have to do with a whole lot less power and they have a lot less capabilities to cool. And therefore, we found that particularly for those companies that want to rehome the crucial IT, particularly for AI, they have different requirements for purchase price and for TCO of solutions that enable them to create their own foundational models based on their own data. And so with us, they would get the data sovereignty back, the control over their own data, and they would get back all of the data that can be retrieved from those models used for their private AI.
And so is it that you're helping more with the bringing of the centers and all of the data usage on location as opposed to in the cloud?
Right. I mean, theoretically, of course, we can do both. But the issue is that there is a whole lot less of a pressure to reduce power consumption with the hyperscalers because they can build their data center where power is cheap and abundant and where they don't have an issue with cooling. Whereas anybody rehoming their IT into on-premises data centers, they are constrained. And so we help those that are constrained before we help the others. It's a much easier deal. It's a much easier sale because ultimately, if you're a hyperscaler and you say, I don't really care how much power I use and what the amount of money it is that I have to spend every year to power those machines, then that is a harder sale to say, hey, we cut your power consumption down. It really all depends on where the pressure points are. And we see the pressure points with those companies that want to rehome their IT.
I see. And so what is it that you guys are doing then to specifically help them on site with the reduction in the power consumption?
That very largely depends on what is called scale out. If you have a system today that is a traditional server with a traditional CPU and a GPU in it, then these things functionally are effectively used as accelerators for AI. But the problem is that they don't scale out terribly well. So if you take 1,000 of them, you don't get 1,000 times the performance of one out of them. Very simply because the interconnect between a GPU and a neighboring GPU isn't scaling out linearly. because there's much more delay in between communication of one GPU to another than it is within a GPU. And what we have developed is a technology by which this delay is minimized, and therefore our scale-out factor is much better. So therefore, in data centers that consists of hundreds or thousands or even tens of thousands of accelerators, that will lead to a much better scale-out factor. And for applications that are used, like the creation of foundational models, we can cut down power between 10%, sometimes 50%, or sometimes even more, depending on what the exact installation size is, what the tools are to create those foundational models, and a whole bunch of other factors that are oftentimes not under control of the user. And we fix that. And if you consider that a data center today is about 100 megawatts, and think about you have 10 of them, you're talking about a gigawatt. Right? A gigawatt at 12 cents per kilowatt hours, sorry for the background noise.
That's okay, I understand.
But at a 12 cent per kilowatt hour cost structure will cost you $1 billion of electricity per year.
Crazy.
Right? And so if you're a hyperscaler, again, then you can put it next to a power plant, nuclear power plant.
Yeah, if you're Elon Musk building his stuff out.
Exactly, right? So that's not a big problem. But if you are facing, as a small or medium-sized enterprise, trying to rehome your IT, if you're facing $1 billion worth of electricity per year, then you will need to rethink what the hell it is that you're doing.
Right. And when was it that you rolled out this service? And is it totally proprietary? Like you have a patent on it? What do those two things look like?
Yeah, so first of all, we are building the processors and accelerators, so it's not a service. You can't do that in software, right? So this has to be done in hardware.
Gotcha.
And that has to be done in specific hardware. And we've made sure that whatever we develop is capable of supporting the frameworks and APIs that are in use today. Most people, if you ask them, they would say we use TensorFlow for this or PyTorch for that. There's a whole bunch of applications and APIs that people use to create not only the foundational models, but also for inference and for agentic AI, right? So there's a whole barrage of technologies, but they all come down to the same exact math. And that's what we do better in a more effective and efficient way when it comes to scaling out, right? So we're at this point in time in the very last stage of what is called logic design. And once we're done with that, we'll conclude with the physical design and then a tape out of a prototype. And then people can have a look at how much we save them with regards to their electricity cost when they deploy our systems. And again, because we're working towards the same frameworks, there is no need for us to be instruction set architecture compatible. It's just you call a function and the function will be executed and it comes back exactly the same way that it does with today's frameworks.
Fantastic. And when do you foresee the prototypes being available?
We anticipate that with funding today, if funding comes in today, it will take us about 21 months to get from money in the bank towards a prototype. And we're, in fact, at this point in time, working on our A round, our first institutional round, to raise that money such that we can support building the team fully and completely to be able to do that. But then again, I've done it before, in fact, many, many times, right? Usually it's money in the bank plus 21 months. I've got a prototype. Then it comes down to, is this prototype capable of production and volume worthy? And then if that is the case, then turning the spigot on to create lots of those processors and accelerators is very straightforward, very quick. If it turns out that we need to do a revision for a mask or for a shrink to support better energy efficiency and cost structure, then we will do that, but that would imply a delay. Right? But those are things that are industry standard practices, so we are not deviating from anything that is in use today and that would be different from any other fabless semiconductor company.
I see. Okay, and so it sounds like you're drawing a lot of experience from your time doing Axiato, if I said that right, and so forth?
Correct. And before that, I did SSR labs and Perimics, so I've been doing this for a very long time. Right? And before that, I did the same stuff at first Siemens Micro, then Infineon, a whole bunch of other companies.
Yeah. Okay. And so you spoke about like a 21-month rollout after funding in place. What would you say is in store for the next 12 months for you in regards to building your business?
Well, as with any fabless semiconductor company, you will see that the most important part is the intellectual property and the team,
Yeah.
right? And so for the IP, we have a lot of IP in-house already. I've created a lot of IP over the past 20 years. And that, of course, to some degree has to be updated. But in general, IP is a very, very important part of any semiconductor company, particularly a fabless semiconductor company. The second most important part, because if there's no IP, then it doesn't matter how good the team is, right? But it's also, you have to balance it. The more IP there is, the better your team has to be, and the more revolutionary the IP is, the more capable the team has to be. And I have collected so far a world-class team in the executive management team and partially even in the engineering team already. So we have a lot of very good engineers, a lot of very good people who can help us make the entire IP that currently exists into a sellable product. So building the team has been a priority for the last over 12, 15 months. And as I said, we have an executive management team in place that is unparalleled. We've got an excellent team. And every part of that member, every part of the team is a member who has been around the block a bunch of times. So nothing's going to fool us anytime soon.
Fantastic. So when you talk about building out the IP even more, is that so you're taking your existing core group of people that you're working with and then bringing on more to build out the IP more, or is it just using that group and then building out the IP more that way?
Yeah, both of the above, because ultimately
I see.
the basic idea that has been patented and is at this point in time published, that was a quantum leap over anything else that's out there. And
Wow.
if you look at that, the patent will show that this is the third time in computer history only that the basic compute paradigm has been changed. Right? The first one was von Neumann, also called Princeton architecture, then came Harvard, and ours is building on Harvard and adding a scale-out port to it because we're not dealing with data centers anymore that consist of a single server. As I said, it's hundreds or thousands or even 10,000s of those machines.
Yeah. And what would you say some cultural or organizational barriers have been when introducing AI solutions, and how have you addressed them?
That's a very good question, and I think your question and my answer will rile a whole lot of people. Because AI to me is a tool. And if you look at the history of humankind, we've always invented tools to make our life easier. And the same way that a hammer is a tool that you can use for good, you can also use it for something bad, right?
Yeah.
And the same is true for every tool that humankind has invented in the last bunch of thousand years. And my simple hope and assumption is that for the most part, we're going to use AI to do something good. Will there be a bunch of rotten apples? Yes, there will be, because if you look at humankind, 3% of all people are bad, right? And so if you look at the use of AI, I can nearly guarantee you that 97% of all of the use of AI will be for a good cause. But there will be 3% that are simply not going to be used for a good cause. And that's just the way it is. And humankind always has been that way, which is why we have police, we have courts, and we have appeals courts, right? Because again, if you think about it, if you always assume 3% of all apples are bad, then 3% of all policemen will be bad. 3% of all lower level judges will be bad, which is why you have appeals courts, right? They can then reverse the actions of those few bad apples in the justice system. That's the way it works.
Yep.
And that's why we have a system that is in place that helps us minimize the impact of the few bad apples that are out there.
Indeed. Yeah. I haven't heard that stat about the 3%, and I hope it's true. I believe that as well in general, percentage-wise apart. I really think that it's certainly a fantastic tool and that a lot more good will come from it than not. And, I heard a statistic recently about like the World Economic Forum and how they were talking about how AI will actually create more jobs than it's displacing. I'm paraphrasing here, but I think that they're talking about by 2030, about 140 million jobs being created by AI and closely associated technologies, with only about 90 million being, obfuscated or taken away or what have you. So it's actually a net positive at what it's creating. And I do believe that in general, yeah, it'll be used for good, and certainly in hopes that all the good will cast a far wider light than the nefarious 3%ers, right?
Correct. Let me give you another example of why I think that AI will be beneficial to humankind.
I'd love to hear it.
Today, when and if we are making decisions, they are either decisions coming from your gut feeling, right?
Yep.
Or they come from decisions based on very few input parameters, and therefore the likelihood that the decision that you're making is the best one that can be made at that time with the data available is very, very low, right? Now, if you see what is available and doable in AI, we can create, let's say, a digital twin of something, and
Sure.
it could be all of society, right? So you create a digital twin of anything, and now you can run a genetic algorithm across all of the possible decisions you can make at any given point in time, and then you choose the best decision and give politicians the input. Say, okay, if you make this decision, humankind will be better off, right? And that's a great helper, because if you look at what is possible using AI today, AI is intended to crunch very large data sets down to something that is as dense as you can make it, and then we can make decisions based on that knowledge that has been acquired, right? And so that requires that you can take anything that there is, any digital twin, any input data you have, and convert that into a foundational model that you then use with the digital twin to make decisions and to make them better and to make them more repeatable. And you have much better justification for why you suggest this particular decision, because you can say, hey, we created that, we had run a digital twin, we have used a genetic algorithm to create all possible decision trees, and here's the best one we can come up with.
And how do your strategies maintain the idea of, keeping compliance with all of the evolving regulations, especially with the fact that it seems as though the US is lagging when compared to Europe? And so what is it, if you can speak to it, what are some of the techniques that you guys are doing to assure clients and data security and that sort of thing on a surface level, we'll say, right?
So if you take the 30,000 foot view, then it becomes very clear why we are going for the control of the data and the return of data sovereignty to the data owners. So what we are saying is, if you're going for something called AGI, artificial general intelligence, then you would have to scrape the entire internet and to figure out a way how to validate each of the input data streams and this and that and that, right? That is very, very difficult. It is humanly not possible to do that. Now, if you step back from this view a little bit and say, hey, I'm doing XYZ, and XYZ is predicated on data that is industry standard and relevant, but there's also my company's experience with this.
Sure.
If you take all that data and take it back from the cloud and put it in your own data center, then you are not in conflict with anything, because ultimately it is your own data and you can do whatever you want with your own data. Extracting high-level data and knowledge out of it is in fact what makes generative AI so compelling, because you can take that data that pertains to your industry, where you don't take any private data from anybody or a competitor, and then you add your own experience from your company to it, then you're not in breach of any laws. In fact, privacy is perfectly maintained.
It's all within house.
Correct, right? And so that's why we are saying that the smartest companies will not use AGI. They will simply take their own data, they will combine that with industry best practices, everything that's available, and where there is no breach of confidentiality, of privacy, and then create the models that are foundational and optimize their own business according to the insights of the data that they have and they own and that have exploited, right? Makes it
Yeah.
very, very simple. And that's why we are very much in favor of rehoming data from the cloud,
Yeah.
not all data, but rehoming the crucial data from the cloud back to on-premises data centers where everybody can extract the knowledge from their own data, from their own experiences, from their own know-how, from their own intellectual property. And that gets rid of every single possibility of a breach of privacy and confidentiality. And that's why we're not advocating take everything in the cloud and then make something out of it. Just rehome your own data and then run it in your own data center to create those foundational models to make sure that your instance of your model doesn't violate anything that would be punishable, right?
Right. Yeah. And how much of a pioneer would you say this idea of rehoming locally, are you, when compared to kind of everyone going out there and using the cloud? Maybe a better way to ask is what percent of it all is using a model such as yours?
So we have, of course, interviewed a lot of our potential customers. And in my personal opinion, over the past 10 months, I've probably talked to about 200 companies. And
oh, wow. Yeah.
The percentage of companies that want to rehome is 100% in my experience. But of course, this is only a very small sample. So I had to look at if there's any market research out, and yes, it is. Gartner had queried tens of thousands of companies, and their quote was that 46% of all companies, I think 46 or 47% of all companies want to rehome their crucial IT to be able to do what I have described. And that makes a lot of sense to me because I took a snapshot of companies that I already knew were predicated on getting the data back. Therefore, it's not very surprising that they said to 100%, yes, we want to do that, right? Because we would be biased and, confirmation bias or not, but I had selected a subset. And therefore, I absolutely believe that Gartner is correct with the 46 or 47%, whatever they had found, that they want to rehome their IT over all of the companies that they have interviewed. Those numbers make perfect sense.
Oh, wow. That sounds like great alignment there. And what would you say that you've done internally to automate your own business so far?
Yeah, of course, we're using AI internally as well. I mean, we would be remiss if we didn't, right? So we use...
Are there specific tools or anything like that you could share?
So we are using the same tools that everybody else is using with the exact same frameworks, but we use them to create certain things that help us document our own internal code better, document processes better, and make sure that the code is optimized towards what we want it to be optimized using AI such that we don't have to do the boring stuff manually. And believe me, when you create chips, you use a language called Verilog, and that can be very, very boring, right? And we all know that engineers don't like boring stuff, so we try to make sure that AI is being used to get rid of all of the boring tasks and only leave the more interesting things where the engineers learn something new to be done by the engineering team versus them having to do all of this stuff, including the boring stuff, right? We don't want that.
Yeah. Can you speak to a case where maybe some AI implementation has led to some unforeseen challenges or setbacks and maybe some key lessons learned around that?
So as I said, we've deployed AI for a very long time internally. And I think the thing we learned the most is that it is pretty good at getting rid of routine work. It is not very good at inventing something new. So if you misuse it by saying, hey, I want to use it now to invent something new, I think everybody will be very surprised that the outcome isn't terribly good. It is generative, but it's not inventive. It's not at a stage yet where AI can invent something new. And I think that's where the big disconnect is. People think it is not only generative, it's also inventive. And that's something that needs to be very clearly said. It's generative, it is not inventive yet. So therefore, I think the learning is that use it for what it can do and don't make it do something it cannot yet do and then be surprised and disappointed by it.
Indeed. And Axel, when you are taking a look at your your growth, how are you measuring success internally? Like, what are your key performance indicator KPIs that you're measuring your company's success against?
Well, there are multiple ways where we measure and where we think we've got a leg ahead above everybody else. We measure productivity, and for the most part, productivity always was measured in lines of code that a developer did per day. And
Okay.
I think that's a metric that isn't particularly good, because at the same time you don't want to encourage verbose code, but you want to have
Right.
comments in the code that explain what the code does, because while every developer, and I can tell you, I've worked with hundreds of ASIC design engineers, they all say when they write the code, oh yeah, it's self-explanatory, I don't need to write comments for it. You couldn't be any more wrong than this, right? And then mostly the surprise comes when you show that developer the code that they wrote 6 months ago, and they're like, what the hell does this do?
You're kidding.
And so the problem is always you have to tell them, and they have to believe you, because if they don't believe you, they don't believe you. They won't write any comments. They won't even write what this code does, what the input is, what the output is, right? All that good stuff. So one of the things that we focused on lately was a tool using AI that helps us create the documentation for the code out of the code itself, right? We're not
As you're going along.
correct. We're not quite going.
Yeah.
We're not quite there yet, but we're working on it, because ultimately, as I said, the developers don't write and don't like to write documentation for anything. So to me, a measure of success is always the quality of the code coverage, and the number of bugs per 100 or 1,000 lines that
Yeah.
are something that I always look at. And I think we look pretty good in what we are doing today. And of course, the code that we create will have to have more verbosity in the headers to tell us what it does, so that people can share it and understand, okay, this is what it does, this is what the expected input is, this is what the expected output is, so that they don't have to read the entire code before they can act upon it. It always helps tremendously with code reuse. If you can reuse code, well, guess what? You save on the development time, you save on the design verification time, you save on the integration time, right? There's a lot of uses for better overview of what it is that you're doing.
Yeah, of course, indeed. And so, wow, it sounds like you've had quite a lot of success both in previous companies and this one, and looking at your next 12 months and 21 with funding or what have you, which maybe can be condensed because of speeds these days. But yeah, that being said, if you were to have a magic wand to fix one thing in your business that maybe is slowing you down or holding you back, what would you say that would be?
Well, the first order of business, of course, like with any business, is have money available to hire the team that I want. Because as I said, we've got the executive management team on board.
Yeah.
Because there may be a bunch of positions that are still open. And the same is true for our engineering and the marketing team. We don't yet have sales because the product isn't done yet. My biggest issue is the wand that I would use is money in the bank today, right? That would be nice.
All right, cash flow.
Because any semiconductor company that you can think of is always taking a lot of money up front. And once the product is out, I wouldn't quite say it's like a license to print money, but the production cost is very low compared to the engineering cost up front. And engineering is always up front. So therefore, you will see that a semiconductor company always has a very big hurdle up front. But once that hurdle is passed, it becomes a very profitable enterprise, because again, the production is relatively affordable compared to other industries where that's not the case. It also, of course, creates a competitive advantage, because not everybody's going to be available and capable of going across the first step and then become a company that has product available. There are always lots of failures in fabulous semiconductor companies, because very simply, the amount of money needed is, of course, a hurdle. But it's also protecting established companies from having too many competitors out there.
For sure.
So it cuts both ways. It's an advantage, it's a disadvantage, but yes, if I had a magic wand, I'd have the money in the bank.
Yeah, there you go. Cash is king. Yeah, indeed. And As we wind up, what would you say some emerging trends are that you think are going to be the most significant in the next 2 to 3 years?
I think in the next 2 to 3 years, we'll see a focus on trying to figure out how to cut the power consumption down because it's at this point in time pretty much unsustainable, right? If you think about the fact that racks are now predicated on being 120 kilowatts, can you feed the energy in? Yes, you can. The problem with that is that now cooling becomes its own science and engineering discipline. That's part.
Right.
The next problem is that at that stage, we have such an ability to crunch numbers and data that feeding the beast is going to be an issue. And therefore, the next thing is co-packaged optics. Because ultimately, electrical connections work well, but they're not working well over long distances. For anything that on a main board, you can still communicate electrically, but even main board to main board, because you can't jump connectors anymore. That's just not possible at the data rates we have today. So everything that needs to be communicated board to board or even rack to rack, that has to be optical, not electrical anymore. And that adds another level of complexity because it adds cost, it adds
in the build out.
Exactly. And it adds, of course, heat, right? And so heat is what we try to all avoid, but you can't avoid it because you need to be able to communicate optically versus electrically between racks and from board to board. I think those are the two biggest things that the industry will have to grapple with in the next 2 to 3 years. And there are solutions out there. In fact, we're working with some of them, but it's something that you already have to do with a cooperation across companies. That's not something a single company can do anymore. I think even IBM would have an issue with figuring out how to do all of these things within one company.
Yeah, it makes me think of, I think it was maybe an LLM or something that was developed by the Chinese at like a fraction of the cost of things. And they did a big solve in the energy component of that. Does that ring a bell to you?
Yeah, so DeepSeek has been famous and infamous at the same time, right? Because
DeepSeek, yeah.
Yeah, they were never able to prove, in fact, that they did the creation of the LLM with less than...
Oh, is that right? Oh, okay.
Can I believe that somebody cut development time down by 50% using 50% less power and therefore 25% of the energy? I think that's possible because ultimately, if you look at what all of this generative AI is, and particularly the creation of a foundation model, that is math, right? And so if you use better math, where you map the math better onto existing hardware, you can cut the time down, you can cut the energy consumption down. I believe all of that. But to a degree that you basically run all of that at like a level of 10% of the development cost, I have a hard time believing that. So did they cheat some? Possibly, probably. I don't know. I can't tell you because I think it never was proven and they never gave any proof for the alleged lack of hardware they needed.
Right.
Again, do I believe that can be done to some degree? Yes. Better math will lead to better results, right? No doubt about that.
Yeah. Thanks for sharing some clarity on that to myself and everyone watching.
So, did DeepSeek deploy vastly more very good mathematicians? Possibly, probably. Will they have been able to cut down the time and the energy? Yes. Was it 5 or 10% effort in the computational effort possible? I sort of doubt that, right? Again, did they cut it down? Very likely.
Yeah. Yep. Let's get some clarity on that to see how we could all employ some efficiencies, 100%.
Yep. Right. So I think
as we wind up also... Oh, sorry?
I think it takes better hardware, it takes better software, it takes more mathematicians because, again, as I said, it's for the most part, it's very well-known math.
Yeah. And how do you see the relationship between AI and human workers evolving over, the upcoming few years, especially in relation to job roles? I know we touched on it a little bit earlier with the WEF, but how about speaking to personal or, professional experience? What does it look like for you guys?
I think at this point in time, a lot of people fear AI, and I'm not sure why.
Yeah.
Because ultimately, as I said, it's really a tool, like any other tool, right?
Right.
What I believe will happen is that those people not using AI, they may have a hard time in the job market. Unless, of course,
Yep.
they are plumbers, because if you're a plumber, you don't care about AI. And that's rightfully so, right? And same
Yeah.
for car mechanics. Auto mechanics will not necessarily have to use AI to the same degree that a white collar worker will have to use it. But I believe that a person using AI will always have a leg up over a person not using AI. A person using AI will have a much better job security than a person not using AI. It is really as simple as
Yeah. 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 And so for those people that are hesitant, they're just dipping their toe in the water,
yeah,
what
try
would
it out.
you suggest to them?
Exactly. Try it out, play with
Yeah.
it, right? Break a bunch of things and then see if you can make it work for you, for your job. I think that's really all that there is. So if there is no
Yeah.
curiosity to try it out, well, I would have a problem with that. If I see anybody in my company not even trying it out, I would have a hard time with that because ultimately I believe if you try it, you will be able to use it in a productive manner that not only secures your job, but also is intellectually satisfying because it elevates the ability of the person to do certain things that prior to using AI they might not have been capable of, right? And if there's one thing that happened and has happened for thousands of years is people got smarter by using more abstract constructs, right? And AI allows us to do that. And therefore, I believe that if you use AI, you will be able to elevate your level of IQ and your experience and your knowledge if you use it properly, right? If you believe everything that comes out of an AI instance, that's probably not a good idea because
Right.
ultimately AI can make mistakes and AI
Oh, indeed.
can have input data that was invalid in the first place. It can hallucinate, right? But if you have a look at the output of the AI instance you're using, and if you look at the output that it creates, and you can verify and validate that is correct, it will elevate your experience with not only the workplace, but also with your intellectual curiosity, right? And I think that's what people should be after no matter what.
Yeah. Yeah. I think that curiosity is a huge driving feature so that people come from that place of growth as opposed to the place of fear around it.
Yep.
Maybe just because they don't know. And so the idea of using it as a tool for the growth that they're having within their own business, but then also within their company's business and kind of elevating that, that's where there's just so much impact that we don't even know, right? We're just tip of the iceberg sort of stuff.
Correct. I fully agree.
Yeah.
And I think the issue is if somebody asks me what AI will be in 5 years, I said, I don't know. I can't tell you because
Yeah.
if you think back 15 years when the iPhone revolutionized the market, right? Did anybody foresee a market for apps on the iPhone? No, of course not, right?
Right.
But that by itself created something nobody could foresee. If you see the amount of apps today that are available for smartphones, it enabled things that were simply not doable prior to that. That was not foreseeable. That's an unknown into the future, right?
Yep.
It's non-linear. You can't predict what it is and what it does. And AI, I think, will do more than that to us.
Oh, yeah. Yep, definitely. Yeah, it's a great analogy. Definitely, going back to the iPhone and what was it then? And, you could go back even further to, the good old cassette tapes that I grew up on playing music and how it's all digital now. And truly AI is reshaping those jumps in technology in ways that we can only imagine. Well, this has been incredibly enlightening. I really appreciate your time here, Axel.
Thank you.
How can people go out and find out more about your company and perhaps reach out to you?
Yeah, so if anybody's interested, they can, of course, always have a look at our website. It's abacus-semi.com. They can have a first glance of what we're doing. And I'm always available through email, no big deal. I'd be happy to answer whatever questions people have. So that's axel.kloth, Kloth, at abacus-semi.com. If they want to reach out, they're more than welcome to reach out. I'll have a look if I have a good answer. If I don't have a good answer, I'll tell them that as well. If I have a good answer, I will, of course, reply back with what I think the answer to the question is. If they have any feedback or any comments, I'd also be more than happy to look into that. And as I said, they're always welcome to contact us and see if we can come up with an answer to any of their questions.
Beautiful. All right. Well, if you would stick around for just a couple minutes, but I want to thank you again very much for this time that you've given me and us, everyone, today. We certainly appreciate it. It's been incredibly enlightening, like I said, and thanks again.
Thank you.